Woodchuck Indexing Router Table System represents a new generation router tool for the woodworking craftsman of the 90s. Combining the smooth mill finish of a router with easy indexing and tapering controls, the Woodchuck turns your router into a horizontal milling station. The Woodchuck allows the creative woodworker a new degree of freedom in combining different cross-sectional shapes along the workpiece length with tapers, flutes, and joinery for an endless variety of combinations. This unique system allows quick mastery of parts previously requiring a copy lathe or complicated hard-to-build jigs. Now the advantage of repeatable precision operations is available to the hobbyist as well as the professional. By combining your router, the Woodchuck Indexing Router System, and your imagination, you can start creating tomorrow, today. Woodchuck Manufacturing. The Woodchuck Indexing Router System is designed and manufactured in Morgan Hill, California, using state-of-the-art technology. As shown here, the initial design work is done on a CAD package, which is a computer-aided design drafting package. This package can model each part in 3D as it's being designed. After each part is designed, it is then programmed in what's called G code for the NC punches. As the code is written, the part can be shown on the screen to QC the part even before it is punched. Here you see the multiple part pattern layout that the NC will punch. After the part has been fully designed and programmed, the G code is then loaded into the NC punch. This machine will hold tolerances within plus or minus 3/1000ths of an inch, ensuring that the parts from each production run are identical. The quality control is double-checked on every operation from programming to finished product, ensuring you the highest grade workmanship and quality possible. Now the punched parts are formed on the brake press. Again, this machine is programmable so that the bends are identical each time they are manufactured. The assemblies are designed to interlock together, making it virtually impossible to misalign any of the parts during the welding procedure. After all the parts have been punched and formed, the assemblies are welded together using a tungsten inert gas welding machine. This type of welding produces a very strong yet cosmetic weld with minimal warpage due to excessive heat. After all parts have been manufactured, each part in the Woodchuck is either painted or plated, depending on the type of surface, for the most durable finish possible. For the painted surfaces, we use the latest in epoxy powder coat technology. All other surfaces are plated to eliminate rust or oxidation and provide a smooth surface for all of the moving parts. Woodchuck Assembly. Assembly of the Woodchuck Indexing Router System is quick and easy. We'll start by applying a light coat of paste wax to the bed tubes and legs to ensure easy assembly and proper operation. Insert one bed tube through the tailstock assembly, positioning approximately midway on the bed tubes. Then repeat this for the second bed tube, tightening the clamps to secure the tubes in place for the following assembly steps. Assemble the 4 mounting plates to the 4 leg tubes. Be sure not to over-tighten, as the plates must pivot freely on the leg tubes. Then insert these 2 legs into the top support assembly from the bottom. Assemble the top support to the bed assembly by sliding the top support onto the bed tubes. Allow the bed tubes to extend approximately 1/2 inch past the end of the top support assembly. Now slide the tailstock assembly up next to the top support assembly and tighten the clamps. This will allow more room for the remaining assembly operations. Insert the remaining 2 legs into the headstock assembly. Now insert the bed tubes into the headstock assembly. Again, let the tubes extend 1/2 inch past the edge of the headstock. Insert the plastic dust caps on both ends of each tube. Attach one end of the tabletop to the leg with the hardware that is provided. Note that the threaded inserts along the edge of the tabletop are to the outside. Now loosen the clamps on the opposite end and bolt the tabletop to the leg as in the previous step. And finally bolt the other tabletop to the opposite side in the same fashion. Attach the fence to the tabletop. Note that the outside edge of the fence is indicated by a small notch in each corner of the outside edge. Now attach the second fence in the same manner as the first, and finally insert a router stop at each end of the table. Now that the woodchuck is assembled, we need to set it up properly to ensure optimum performance. If a light coat of wax is applied to the table surface, the router base will slide smoothly, ensuring that the cuts are even. This will also protect the painted surfaces. Although it's not necessary, it is preferred that the tables be level. If they are not exactly level, it is very important that they be parallel to each other so that the router lays perpendicular to the workpiece at any point along the table. Now that the woodchuck is properly set up, let's take a look at some of the different types of routers and how to prepare them for working on the woodchuck. Standard routers are suitable for all woodchuck operations, especially when enhanced by the 2-piece universal router base provided. Plunge routers are excellent but not necessary for repeat work or deep cuts. Many plunge routers have triple depth stops. This feature can make production setups much simpler. The woodchuck will operate with both 1/4 inch and 1/2 inch collet routers. 1/4 inch routers employ smaller cutters and mean that the operator should take cuts only as deep as appropriate for the horsepower and capacity of the router, or a shortened router and bit life as well as low quality cutting will result. Always keep in mind that the router is a high-speed cutting tool. You should treat it with respect and keep the following safety precautions in mind. Always follow instructions and safety precautions suggested by your router manufacturer. Wear the proper eye and ear protection. Do not force the router. The woodchuck was designed to use the router with a feel not force technique. The router will cut smoother and safer when used as it was intended. Be sure the bit is not contacting the work before you switch the router on, and do not move the router following a cut until the bit has come to a complete stop. A 2-piece universal router base is provided with the woodchuck system. It is not necessary that you mount this base on your router to use the system. However, it will enhance the system's performance. Simply remove the phenolic base from your router and replace it with the universal base plate using the original hardware. Woodchuck features. Now that we have the woodchuck fully assembled and set up, let's take a look at the features that make the woodchuck unique. The first feature is the auto-centering quick-release hubs. The woodchuck comes standard with 4 sets and additional sets are available. The patented auto-centering hub has 4 tapered pins that automatically locks each workpiece squarely into the indexing system. No matter how you insert the workpiece, it will always index to the same location. The other hub allows you to quickly release a workpiece to inspect your work closely or to replace it with a second piece for production type work. The third feature is the auto-indexing headstock. Once the work has been mounted into the woodchuck, it can be milled into a 3, 4, 6, 8, or multi-sided part with up to 36 equally spaced sides. The thumb screw allows you to quickly change the indexing plate. The woodchuck comes standard with a 16 and a 24 position plate. These plates allow you to make cuts on 2, 3, 4, 6, 8, 12, 16, and 24 equally spaced sides. The tapered indexing pin assures that the work is locked in at the correct angle of rotation. It can also be released to make circular molding cuts. Now let's look at the tailstock assembly. The quick release clamp makes removal of work quick and easy. Quick release handles let you easily set the tailstock to the proper position for different lengths of wood. The next feature that makes the woodchuck unique is its adjustable bed. You can taper your work in either direction, and the router table will stay level for ease of use. Both the headstock and top support adjust easily and lock securely in place with the quick release handles. The maximum angle is 13.25 degrees. Adjustable fences control the exact angle and offset for each cut. This feature makes centered or offset fluting easy and accurate. When cutting a flat surface, the fences are opened as wide as possible for free hand routing. Then when a decorative cut like a flute is required, the fences are set to restrict the router travel. Adjustable router stops control the cut lengths of surfaces, flutes, or mortises. And finally, the woodchuck comes with a 2-piece universal router base. This base serves 3 basic purposes. First, it extends the base of the router for the widest possible surface to be routed. Second, the Lexan plate provides a very smooth surface for the router to glide along the table. Third, it keeps the router square to the fences and stops for precision cuts. Before we start using the woodchuck, you need to be aware of the physical size limitations for the workpiece itself. The maximum length of the workpiece for the model IRT-33 is 33 inches. If you require longer workpieces, there is an 80-inch upgrade available, which will allow you to build pencil post beds, pillars, and etc. The maximum diameter of any workpiece is 9 inches. However, the maximum cross-sectional thickness depends upon the number of sides and the surface cut width. The maximum width of any surface that can be cut on the woodchuck is 3.5 inches. Therefore, if you want a 4-sided post, the maximum cross-sectional thickness would be 3.5 inches, and the diagonal cross-section or diameter would be 4.95 inches. Now as you increase the number of sides, you will also increase the maximum cross-sectional thickness and diameter of your workpiece. For example, if an 8-sided workpiece has a surface width of 3 inches, the cross-sectional thickness will be 7.25 inches. Use this formula to calculate the surface width for a desired cross-sectional thickness, where S equals the surface width, C equals the cross-sectional thickness, and N equals the number of sides. For example, if the desired cross-sectional thickness equals 3 inches and you want to make a 6-sided workpiece, the surface width will be 3 times the tangent of 30, which equals 3 times 0.5774, which equals 1.7322, or approximately 1 3/4 inches. Use this formula to calculate the cross-sectional thickness for a desired surface width, where S equals the surface width, C equals the cross-sectional thickness, and N equals the number of sides. For example, if the desired surface width equals 1 inch and you want to make 8 sides, the cross-sectional thickness will equal 1 divided by the tangent of 22.5, which equals 1 divided by 0.4142, which equals 2.4142926, or approximately 2 5/16 inches. Now let's take a look at how easy it is to prepare your workpiece for the Woodchuck. Woodchuck can save you time and money by allowing you to use wood that would normally be discarded or would take considerable time in truing. Several boards can be glued up to make any size cross-section desired. These glue-ups do not need to be trued or surfaced prior to any routing operations in the Woodchuck. First, you simply want to square the two ends so that the workpiece spins freely in the Woodchuck. Next, we draw crosshairs on the workpiece. The closer these are to the true center of the workpiece, the less material you will need to take off to finish the surface. Now we'll simply mount the indexing hub with 2 flathead wood screws. Again, the closer to center and the more square we mount it, the less material we will need to take off to give us a finished surface. And finally, we mount the small hub to the opposite end with a single flathead wood screw. Woodchuck technique. Now let's take a look at the techniques used in creating something like this piece shown here. We'll start by taking a look at how to cut flat surfaces on one or more sides. First, we'll set the fences for the maximum router travel. And then set the router stops for the desired cut length. Since most woodchuck operations involve large amounts of stock removal, the most often used bits will be the surface planer, 2 flat-ended or similar shape. In order to avoid chipping out the wood in front of the bit, you'll want to move the router in the direction that keeps the bit cutting into the wood. This will give you a nice smooth surface and clean-cut edges. When routing a large area, use the climb milling technique to minimize tear-outs and splintering. Route in a clockwise direction around the outside of the work, working towards the center as you go, leaving the last strip of stock to be removed approximately half the bit diameter. Here we have a finished surface that requires little or no sanding. To cut a perfectly square piece, simply rotate the work 90 degrees and make the next cut. Start the router away from the wood to keep it from jumping. Then simply cut the surface area in a clockwise direction, working to the center. When you finish cutting all 4 sides, your work will be perfectly square and the finish will be beautiful. Any number of sides can be created by using the exact same technique. You simply choose the indexing plate that will give you the number of sides desired. The 16 and 24 position indexing plates come standard with the Woodchuck. And as mentioned before, custom indexing plates are available. Surfaces can be tapered in either or both directions. Simply set the adjustable bed for the desired angle and cut the surfaces using the same cutting technique. If you want to cut the taper on a specific angle measured in degrees, use this formula to calculate the measurement difference for the bed tubes. For example, if you want to taper your workpiece on a 2-degree angle, the measurement difference would equal the tangent of 2 times 48, or 0.0349 times 48, which equals 1.6752 or 1 5/8 inches. Measure from the workbench to the bottom of the tubes at one end, and then set the opposite end 1 5/8 inches either higher or lower, depending on which way you want the taper. Or simply use any angle finder. Now simply cut the surfaces using the same technique previously illustrated. Cut your first surface and then index to the next. Simply repeat this process through 360 degrees around your workpiece. After all surfaces are milled, the workpiece will be perfectly symmetrical. Flutes can be easily cut on any or all surfaces. They can be centered, offset, straight, circular, or tapered. Select the bit for any style of fluting desired. Here we'll use a roundover or core box bit. Again, we'll set the fences and stops. Then start with the bit off the wood by tipping the router up. Then slowly rock the bit into the wood and slide the router along the fence to the opposite router stop and back. Now simply rotate the indexing head to the next surface to be routed and cut the next flute. Repeat this process for as many times as desired. Decorative molding cuts are also easily made and add a touch of class. For this cut, we'll use a 45-degree taper cutter or V-groove bit. First, we'll set the fences so that the router is centered on the workpiece, and then set the router stops so that it holds the router firmly in place. Again, we'll start with the bit off the wood by tipping the router up and rocking it into the workpiece. Now rotate the indexing head through 360 degrees to create this simple accent cut. The joinery is one of the most important jobs while working with wood. Precision joinery can make the difference between a family heirloom and just another workbench for the garage. First, we'll look at how simple it is to do mortises. For a mortise cut, we'll use a 2-flute spiral cutter to lift the chips up out of the workpiece. First, set the fences and router stops for the desired width and length of the mortise. Then simply cut the mortise in a clockwise direction. If necessary, adjust the depth of the cutter again and repeat the same process. Now let's take a look at how to make a slotted dovetail. Because of the shape of the dovetail bit, it must be cut in one pass. So we will first relieve the work with a straight cutter on all of the sides where we want the dovetail joint. Then we'll use the dovetail bit. Now simply repeat the same technique on all surfaces where you want the slotted dovetail. Now we'll take a look at how easy it is to make a simple lap joint. Either a surface planer or a 2-flute spiral bit can be used. Here we'll use the 2-flute spiral. First, we'll open the fences as wide as desired, and then set the router stops for the desired width of the cut. Now use the standard cutting technique to remove all of the material. Making this very simple and common type of joint is fast and accurate with the Woodchuck. Notice how smooth the surface is for gluing the joint. Now you are prepared with the basic techniques to use your Woodchuck. The only limit that you have is your own imagination. The Woodchuck can be extended to 80 inches by purchasing the extension upgrade, which includes additional top rails and fences, as well as extended bed rails. The remaining portion of this videotape shows the assembly of the concentric spiral upgrade, which can be purchased as a package or added at a later date. To start this assembly, take out the 6 thumb screws that hold the fences in place and remove the 2 fences. Replace these fences with the fences which are provided in the upgrade package. Note the fence orientation in relation to the indexing head. Shown here is the carrier bracket which drives your router along the table. Later we will show how this is attached. Next, install all of the fence thumb screws except for the one positioned in the carrier tray. Note this screw is longer. Now remove the indexing plate and lock the indexing pin in with the stops applied. The indexing pin remains disengaged throughout normal operation. However, it can be used to locate multiple starts around the workpiece by disengaging the gears, rotating the work, and engaging the gears. Now install the pivot arm by sliding it over both shafts. This pivot arm allows the drive system to work regardless of the headstock position. Next, replace the indexing plate with the indexing spur gear, which includes the indexing holes. And then engage the gears and tighten the thumb screw. Now we will install one of the 3 45-tooth spur gears, followed by a large washer, the desired drive spur gear, a second large washer, the handle, and then the thumb screw. These large washers ensure gear alignment even when cutting spirals on a taper. Loosen the thumb screw, engage the spur gears for minimal backlash, and retighten the thumb screws. This is the standard configuration for cutting right-hand spirals only. Next we'll show the installation of the left-handed spiral drive. First, remove the 4 nuts from the drive screw mounting tray. Insert the carrier tray and replace the 4 nuts. Sliding the carrier tray in to engage the gears and tighten the nuts. Next, install the long fence thumb screw. To reverse the action for left-handed spirals, disengage the gears and move the handle, 2 large washers, and drive gear to the reverse carrier. Move the spacer bushing from the reverse carrier to the drive screw shaft. Replace the thumb screws and finally engage the gears. Now you can see the left-hand configuration. To connect your router to the drive system, install the router carrier bracket as shown. Next, rotate the bracket onto the router base and move the router base tight against the fence to tighten the nuts. Next, move the opposite fence against the router base and tighten the 3 thumb screws. Make sure the fences are parallel and centered on the workpiece. To change the pitch or the distance traveled by the router per 1 revolution of the workpiece, disengage the gears, remove the handle and 1 washer. Next, change to the desired gear. There are 4 supplied for 3, 4, 5, and 6 inches per revolution. Then replace the washer and drive handle and engage the gears. You are now prepared to cut both left and right-hand spirals. If you require more assistance, call us at our toll-free customer service number. That's 1-800-279-4570. Again, 1-800-279-4570.